In this video, we are going to see how routers follow traffic from one network to another. Router is a layer 3 device and it operates in the layer 3 of the OSI model. That means it uses IP address to route traffic from one network to the other. So here I have two networks, 10.1 on network A, 11.1 on network B. So going on to see the IP address. So we can just show IP and we have the IP address over here. So at the moment the switch is down, the router is also down. So we have to go ahead and turn these devices on. Start. And let's configure our interfaces, our default gateway. Okay. So I'm going to configure the various interfaces. As you can see here, interface 00, interface 01. So config T, interface, fast Ethernet 00, IP address of 10.10.254.245.245.245.0 subnet mask, and we're going to now show the interface. So interface fast Ethernet 01, IP address is 10.10.11.254.245.245.245.0. No shot to the interface. Right. So on this switch, let's see the MAC address table. Show MAC address table, and that's the MAC address for the router. Right. So we are going to start a capture here. Start capture, and then we are going to ping. We are going to start a capture here on PC3. Start cap. Oh, okay. Start capture. Same here. Start capture. Okay, that's for PC4. And where is PC3? Okay, and that's PC caption. Okay, for this network. Okay, let's capture PC3. Okay, so I think we are good to go. So we are going to ping PC4 on a different subnet from PC1, and we're going to see the traffic that is going to pass through from network A to network B. So I'll do a ping. I seem to have an interface, a window for PC1 already. Okay, not really. Ping 10.10.11.2. Timeout reply. Yeah, the timeout it timed out because on the first packet because it was trying to learn the route from network A to network B. So now let's see what really happened as we issue the ping command. So this is router 1. Okay, and then we have this is PC4 route. Okay, And let's look it for PC3. Okay, so um, this is the interface we try to capture this one. Let's go ahead and read what's going on there. So first I'll look for ARP, Advanced Resolution Protocol, and here's the broadcast. And let me open PC1 and show IP address. Notice something here. Here's the MAC address of PC1. First, it sends a broadcast asking who has 254. And here is it. It's asking for who has 254 because 254 is the default gateway. Tell 10.1. Tell me who has 254. And it replies back to okay. So it replies back to here you can see the destination is PC1 asking for who has 254 because it's the default gateway. At that very same moment, let's check on this one is PC4. Okay, let's go to PC3 first. So this is PC3. Let's search for ARP. So look something here. 254 PC1 was asking for who has 254 because 254 was the default gateway. So any traffic from network A traveling to network B will first hit the gateway. And as you can see here, it hit the gateway over here. And now 254 as the gateway replies to 10.1 over here, which is PC1, that hey, I'm 10.254, I'm at this MAC address, and therefore we are in the same local subnet, and therefore the MAC address has been resolved. But this is the situation. 10.1 wants to travel to 10.3. So on PC3, you see a broadcast has been received who has 10.11.2, and that's PC4 being asked by 11.254. 11.254 is the default gateway for network 2, and this is network 2. So the traffic from here has been forwarded to this network, acting as the intermediary, and it's asking who has 254, who has 11.2, tell 254, so that the traffic can be transferred back to network A. But there was no response from PC3 because the destination address is in PC3. So even if you search for ICM ping, there is no ICM ping, echo reply, nor echo request. Why? Because PC3 wasn't the destination, right? So let's go to PC4 and analyze something here. First, I'll search for ARP. So the gateway for network 2 was looking for gateway for network 2 is looking for 11.2. Tell 11.2 that so another ARP broadcast request was being sent by 10.11.2 being asked by 11.254, which is the default gateway. So 254 was able to resolve the MAC address of 11.2, which happens to be in the same local subnet. So as you can see here, the destination the IP has been resolved to a MAC address which happens to be in the same local address or local network or MAC address table of network B. And therefore, if we search for ICM pings, you can see here. So 10.2 echo reply responds to 10.1, and here is it. So source 10.1 has not packed the traffic from 10.1 first hit the gateway over here, and then because a router is able to route two networks together, the network was routed through the interface of fast 00 to fast 01 to this network, and then the gateway will resolve or check the local network to see if the IP address is in the local subnet, and therefore resolves it into the MAC address of that local PC here. So we have 10.1 over here. It's in this network and it's able to communicate to. So simply it means, hey, I'm 10.1. I'm looking for 10.2. 10.2, I'm here. It happens all after the IP address. The traffic has been forwarded from one network to the other, and then the MAC address has been resolved in the other network or in both networks. So they're able to communicate together. So 11.2, which is in a different subnet, is able to communicate with 10.1 that, hey, I'm here. Meanwhile, they are in a different subnet. So generally, traffic travels from here to this gateway and is then forwarded to this gateway, and then the IP address will be resolved into a MAC address in the local network to see if the IP address is in the local network, and therefore it forwards the traffic back to the um, previous source where the traffic came from. So if we check the address resolution protocol table for the router, you can see that it has resolved um, the IPs 10.1 for this PC because traffic was sent from PC1 to PC2. It learned about the IP address of PC1 and then PC2, and therefore learn about the gateways being connected to it. So therefore, routers forward traffic based on IP address, and as you can see, it has the IP address of every traffic flowing through its interfaces to and from one network to the other. So it's been a long video, but generally that's how routers forward traffic from one network to the another, and I hope you get a better understanding. And then if any questions, leave it in the comment section below and I'll respond to you. Thank you.